This is a sampling and preservation for the membrane inlet mass spectrometer that measures dissolved gases such as oxygen, nitrogen, and argon. So basically what we have here to start with is our 140 milliliter syringe. And the reason we have that is because we are taking replicates for our MIMS samples. So we'll push through certain milliliters, so it's going to require this whole syringe. And in addition to our syringe, we also have our stopcock, which allows us to close certain valves and connect to our syringe and this port that we have here. And so when I start beforehand, basically I'll turn this stopcock, and so this valve right here is off, and so nothing's going to get in once I put it underwater to grab my water sample. But here, this red arrow is pointed forward towards the 140 milliliter syringe, as well as this rubber tubing we have here that'll be underwater is also open. So as we pull, this is going to have water coming through it, and slowly we will do that to get our sample in. But first, just a cleaning technique, and just to make sure that we clean out our syringe. Let's say we were at a stream site before this. We would clean our syringe 3 times. So pull up a good amount of water, and then you can pull it through, shake it, and then push it through. And we'll repeat this 2 more times just for good cleaning and lab techniques, field techniques. Yeah. Or you're really strong and you just pull it right off. Okay, I'll do 1 more. So once we've cleaned out our syringe, now we can start with our water collection. So this is definitely going to be a process, and it takes a while, but this is where patience is key. And yeah. So what I did, just to be clear, is I turned my stopcock off to here because I'm not pushing out water through there anymore. And again, I have the red arrows pointed to the 2 entryways that I want to hit, which is here, which is going to pull the water in as I pull through here. So I'm going to put this underwater, and I will just slowly pull. And your first go abouts, you'll notice instant bubbles. So what I do is I take it up. Normally your syringe probably won't have water flowing through like that, and I'm just going to tap to get all the bubbles out. And also you can put it on the side because you might have like little bubbles on the syringe, and just kind of rotate it around to gather those and just hit it. And so now I have my bubbles at the top of my syringe. So what I'm going to do is I'm going to push out, but as I push out, I'm going to instantly put it back into water, and I'm going to push the rest of that water out. So I'm going to try again to grab my water sample. And it's really slow. Like, this isn't something you want to rush because you want to get the best MIMS sample possible, especially because those bubbles can contaminate and kind of ruin your sample. But yeah, feeling good about this one. So we will see what happens. But as you can see, it's a very slow process, but slow and steady wins the race for MIMS. Okay, so I got my 140, and that looks pretty good. Yeah. Okay, so one thing I'm looking for is previously beforehand there was a really big sample, and so when I knocked the side of this syringe, the bubble went immediately to the top, and so that's one thing I'm looking for, is that really big bubble that could compromise the sample. And then also I'm looking, okay, are there any big bubbles along this black piece of the syringe? And if there are, it's like tapping them, and if they are going to compromise the sample, like they'll float up to the top, and that's where I'll have to like restart, where I'll push through again and go underwater. But in this case, like very itty bitty bubbles that aren't going, you're going to have them nonetheless, but they're very minimal and not going to affect the sample. So we are able to move on to our placing this in the vials.